Hi everyone, my name is Pradyumn Kejriwal, and today we will discuss the solution to the 11th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. As you can see, I have my sheet right here and I'll open the problem. Okay, so the problem is called add modulo 10 and it is like you are given an array of n integers a1 to an. You can apply the following operation any number of times. Select an index I and replace the value of the element ai with the value of ai plus ai mod 10, where ai mod 10 is the remainder if you divide ai by 10. For a single index, this operation can be applied multiple times. If the operation is applied repeatedly on the same index, then the current value of ai is taken into account each time. For example, if ai is 47, then if you do one operation, then you add 7 because 7 is the unit digit, so it becomes 54, right? And if you add one more time, then this 4 will be added, so it becomes 58, right? Check if it is possible to make all the array elements equal by applying multiple operations or possibly 0 as well, right? And then they have given an example. So yeah, the problem is that you have an array, right? An array which is a1, a2 up to an, right? And what you can do is, in one operation you can do ai plus equals to ai mod 10. So like the unit digit of ai you can add by 10, right? And we need to determine that can we make all the elements of this array equal using the operations. Any number of operations we can do, including 0 operations, right? So for example, they have given that if you have 6 comma 11 as the array, then what is the answer? So if you have 6 comma 11 as the array, then what you can do is do one operation on this index, right? So what you will do is 6 plus the unit digit with 6, right? So it becomes 12. So you get 12 comma 11, and then you will also do it to this index, the operation. So if you just add the unit digit, which is 1, it becomes 11 plus 1, which is 12, right? So we have 12 comma 12, and therefore all the elements of the array have become equal. And so the answer is yes, that it is possible to make all the elements equal using the operations. Like in this case, you can see that we applied one operation to each index, but we can apply multiple as well. And we could also do, like, we can apply different number of operations and do different indices. Like we could have applied 3 times to this one, but only 2 times to this one or something, right? So yeah, and let's say one more sample if we discuss. Let's say we discuss 1, 2, 4, 8. So if we have 1, 2, 4 and 8, what we can do is we can make all of these 8. Like how? I can change this 1 to 2, then 2 to 4, and then 4 to 8, just adding the unit digit each time, right? And then 2 to 4 and 4 to 8, and also this 4 to 8. So now all the elements have become equal to 8, and therefore the answer is yes, right? And in similar fashion, you can just try all of the sample test cases if you want for your satisfaction, right? So yeah, this was the problem, and the constraints here are that n is up to 2e5, right? And sum of n also is given up to 2e5, and ai is up to 10 to the power 9, right? So since you know that in one test, in 1 second, we can do around 10 to the power operations, right, per second. So what we can do here, like since n is less than equal to 2e5, we can simply like do O of n or O of n log n approach, because this is like 2e5 and this is around 20 into 2e5 or something, right? If I take the base as 2, this log base 2, and O of n square will not pass because it goes to around 4e10, like 10 to the power 10, but the limit is 10 to the power 8 only. So this one is 100 times slower, right? So definitely it will not pass. Okay. So yeah, now you can just try to pause the video and solve the problem by yourself. Alright, so at this point, I'm assuming that you have tried the problem by yourself and want the solution. So, okay, first thing that we should do is that since we are playing so much with the unit digits, like if we have a number 46, then when we do the operation, we add 6, which is a unit digit, right? So since we are playing a lot with the unit digit, let us see that how it changes when we do the operations. Like let's say we have a number with 1 as the unit digit. So if we do the operation on this, we'll add 1, right? So it becomes 62. That is, the unit digit becomes 2. So if we have 1, it becomes 2, right? And if we have 2, let's say, and we do the operation, then it becomes 64. That is, it becomes 4, right? And if we have 4 as the unit digit and we do the operation, it becomes 8, right? And again, if we have 8 and we do the operation, like adding 8, it becomes 6, right? And if we have 6 and like we add 6 one more time, it becomes 2, the unit digit, right? And similarly, you can find out for all the other numbers. Like let's say for 3, it becomes 6, right? 3 becomes 6. Then similarly 9 becomes 8. You can see that. And 7 becomes 4. Okay. And what we can see is that your, like, what is left? 5 and 0, right? If you have 5 as the unit digit, then if you do the operation, let's say this, if you do the operation, it becomes 0, right? So 5 becomes 0. And what about 0? 0 still remains 0 only. Like if we have 70 and we do add 0, it remains 0 only, right? Okay, so this is our kind of a graph which shows to us that how the unit digit changes, like when you do the operations. Okay, so from one thing that you can notice from here is that these odd numbers that we have here, these odd numbers change to even when you do the operation. Like if we have an odd number, let's say 63, then if you do the operation, it becomes even 66, right? So all the odd digits that we have, they become even after doing the operation, right? But if we have even number, like these 4 even numbers or this 0, so if we have the even number, they will remain even only, right? They can't become odd. Okay, so if we have even number, they will remain even, they can't become odd, right? So if in an array, if we have both even and odd numbers, let's say our array is like this. Okay, so this is our array. In this we have both odd and even numbers. So of course we cannot convert even to odd, right? We can't convert this even to odd. So of course we'll have to convert all the odds to the even. So this is odd. So we will have to convert this to an even. So we'll have to do one operation on this, right? So let's just always convert all the odd numbers in our array to even numbers whenever we have odd, right? Just by doing one operation, you can do that. So basically, our step one is that convert all odd to even numbers, right? So now you have only even numbers. At this point, you have done this step 1, and now you have only even numbers, right? So basically you have only the last digits as 0, 2, 4, 6 and 8. Only these last digits you have right now. Okay, all right. So now can we make them equal or not? We have to just check that. So okay, for now let's say that my array has a 20 and also a 26, like, and also some other elements. I don't care about them. Like I have these 2 elements in my array, just let's say for example. Okay, so I can simply prove that the answer to this test case would be no. Like it would be no. Okay, and why do I say that? It is because one of my elements is 0 right here, and the other one is non-zero. Okay, so since this one is 0, right, it is 0. So in this graph we can see that 0 only remains 0 only. Like if we have a 0, it remains 0 only. Whatever we do, it will remain 0, right? And if we have a non-zero, like a 6 right here, right, if we have a 6, then that 6 can become like 2, then 2 can become 4, but 4 can become 8, and then 8 can again become 6. Like in this graph you can see 6 becomes 2, 2 becomes 4, 4 becomes 8, and so on. But this 6 can never become equal to 0. Like whatever we do, this 6 can become equal to 0, but also 0 can not be equal to 6. Like, so my point is that these two numbers can't convert to the other one. Like if we have a 0 at the end, it will remain 0, and if we have a 6 at the end, it will remain either 2, 4, 6 or 8. It can't become 0. So definitely the answer would be no. Why? Because we have both zeros and non-zeros in our array. Like since these 4 are non-zero, they will remain non-zero. As you can see here, these 2, 4, 6 and 8, these 2, 4, 6 and 8, they will remain non-zero. So if we have a 0 also and a non-zero also, we cannot do it. Okay, so if we have case 1, if we have both 0 and non-zero, both 0 and non-zero in our array, then the answer is no. Okay, then let's say case 2 is we have all non-zero, or let's say we have all 0 for now. Okay, we have all 0 unit digit. Okay, like let's say we have 30, 40, 50. All right, then what is the answer to this? What is the answer? So in this case, it is pretty simple to observe that if you have a 0 in a number, then if you do the operation, it does nothing to the number. Like essentially, if you have a 0, then you can't change that number again, right? Because adding 0 does nothing, right? So if you have all zeros in your array, then you cannot change any number at all, right? So if they are not already equal, then you can't make them equal. So like in this case, the answer would be no, right? But if they're already equal, let's say 50, 50 and 50, right, then in that case your answer would be yes, right? Because they are already equal, so of course the answer is yes, because we want to make them equal, right? So in the case of all 0, if we have all zeros in our array, then if we have all already not equal, then the answer is no. And if we have all equal, then the answer is yes. All right, so we have these two cases, that either we have both 0 and non-zero in our array, or we have all 0 in our array, right? But the third case, what about the third case where we have all non-zero? If we have all non-zero in our array, right, so that means that we have only 2, 4, 6 and 8, 2, 4, 6 and 8 in our array. Because remember, we had done the step 1. The step 1 was to make all the odds to even, right? So if we have a non-zero even number, that means we have 2, 4, 6 and 8 as the unit digit, right? So now can we determine that, can we make them equal? How do we check that? So for that, I have a simple observation that I can show you. Okay, so like we made a graph here, right, which had all the odd numbers also and 5 and 0 also, but these for now we have only these 4 numbers, right, 2, 4, 6 and 8. So I'll just make them again, that if we have 2, it becomes 4 on one operation, and if we have 4, it becomes 8, and if we have an 8, it becomes 6, and if we have 6, it becomes 2, right? That's how they change, correct? So let's say if we have 72, we can do one operation and become 74, and then again we can do one operation and it becomes 78, and again we can do one operation and it becomes plus 8, so 86, and we can again do an operation and it becomes 92. right? So initially we were at 2, and then again we completed one cycle, and we are again at 2, right? And as you can see that like while we are moving from 2 to 4, we are adding 2, then from 4 to 8 we are adding 4, then from 8 to 6 we are adding 8, and here we are adding 6, like when we do the operation. So in one cycle you can see that we are adding 20 total, like 2 plus 4 6 plus 8 14 plus 6 20. So in one complete cycle we are adding 20, as you can see right here also, that we were at 72 and we added 20 essentially, and we reached 92, right? So if we have an array which has all 2 4 6 8, then like any element ai that I have, if I have ai, then I can add 20 to it in this one cycle. Okay, in fact I can add 20 as many times as I like I can add one more 20 to it by doing the operations 4 more times, right? I can make this 92 as 112 also by doing it 4 more times, like doing one more cycle, right? So I can add 20 as much as I want. So like if I have ai, I can make ai plus 20k as well. Okay, so this power I have, like this is a very nice power, that if I have ai, I can just add 20 as many times as I want, right? And okay, just remember that here we have all the elements in our array as like the unit digit is 2 4 6 and 8, right? So in our final array we want all to be equal, all the numbers to be equal. So that means that their unit digit also is equal. Like if we have all the numbers equal to some x, then of course all the unit digit will also be equal, right? And since we know that if we have either 2 4 6 or 8, then it will remain this only, it cannot become any other number, right? So if in our array we have the numbers which are all either of this, then they will remain these 4 only, right? So we can make the final number either 2 or 4 or 6 or 8. Okay, so let's say we try to make all of them 2. All right, so for example if we have 14, then we have 18, or let's say we have 32, then let's say we have 56, or let's say we have 46. Okay, and then let's say what we have 58. Okay, so we have these 4 numbers and I want to make them equal, like I want to check if I can make them equal or not. So first what we'll try to do is make all the unit digit, make all unit digit 2, right? And we can do that, right? Because we know that in our array we currently have only these 4 numbers, these 4 numbers only, and all of these 4 numbers can be done in a cycle. Like if I have 4, then I can do it 3 times to reach to 2, and if I have an 8, I can make 2 in 2 moves, and if I have 6, I can make 2 in 1 move, right? So I will just make all of them to 2, and let's see what happens. Okay, so this 14 I want to make it 2, like the unit digit to be 2. So what will it become? 18, then 26, then 32, right? Then I have 32 right here, already 2, then 46. So this I can make 52, right? 52, and I have 58, so I can make it 66, and then I can add 2, it becomes 72, right? So this way I have just added some like I have just done some operations and made all of them 2, the unit digit 2, and then now I can use this power of adding 20 any number of times, and I can just add 20 and make all 72. Like I can add 20 to this 2 times, so I can add 40 to this, I can add 40 to this, I can add 20 to this, and I just keep it the same. So I'll end up with all with 72, 72 and 72. So that's what I can do. Like first I will try to make all the unit digit equal to 2, and then I will make them equal just by using our plus 20 power. But it might happen that we can't do that. Like for example, if we have 12 and then we have 34, okay, or let's say we have 44, all right, 44, then let's try to do the same thing. We have 44 here and we have 12 here, so this is already 2. But this one we can make 2 by adding 4 to it, so 48, then 56 and 62, right? So we can make it 62 by doing it 3 times. So we have 12 and we have 62. So we can add, let's say 20 to it, it becomes 32, and we can add one more 20, it becomes 52, right? So 52 we have and 62 we have. So now clearly we can't just make them equal just by adding 20. And why? Because by adding 20, like it is pretty clear, right? The difference is 10, and clearly we cannot like make this difference 0 by adding 20, right? So we are stuck right here. So in this case the answer is no. Okay, but why this happened? This happened because, like, if we have AI and we add 20 to it any number of times, then its remainder with 20 won't change, right? Like if I have 12, then its remainder 20 is still 12, like 12 mod 20 is 12. Okay, so no matter how many times I add 20 to it, like let's say I add 23 times, that is I add 60 to it, so it is 72. So now 72 mod 12 is still 12, sorry, not 72 mod 20 is still 12. So what my point is that adding 20 to my numbers as many times as I like won't change the mod with 20. So if initially their mod with 20 is not equal, then I can't make them equal. Like here I made this 12, like 12 is fine, but this 44 I made 62, right? And then I tried to make them equal, but I can't do that. Why? Because this 12 mod 20 is 12, but 62 mod 20 is only 2. So since they are not equal, I can't make them equal, and hence the answer is no. Okay, so this might be a little complicated, so you can try to pause the video and think about it, or I'll explain again. Like what I'm simply doing here is that if I have only 2, 4, 6 and 8 in my array, okay, only these numbers in my array, then of course they can only become either of these 4 numbers, right? So let us just try to make them all equal to 2. Okay, so to do that, first I'll make them equal to 2, right? And then I will use this power of adding 20 to my numbers and make all the numbers equal. Okay, so in this case we could do that, right? So first we made this 14 to 32, then this 32 already is 2, so it 32 it is, and we made this 46 to 52 and 58 to 72 just by adding it 2 times. So here you can see that if we take the remainder with 20 for all of these numbers, we'll get 12. Okay, 32 mod 20 is 12, 32 mod 20 is 12, 52 mod 20 is 12, and 72 mod 20 is 12. So as you can see that if we take mod with 20, it remains same. That means that we can make them all equal just by adding 20 repeatedly, right? And that's why the answer is yes. But in this case, we saw that after converting, we don't have the same mod with 20, and that's why we cannot make them equal. Okay, so you might be thinking that why did we choose 2? Like why we tried to make all the numbers unit digit to be 2? Like what if they want to be 4? For example, if we have 14, like if we have 14 and we have 18, then in this case you might think that we can just add 4 to it and become 18, 18. So in this case, finally they are not equal to 2. So why are we always trying to make them 2? So in this, like, the answer to this is that if we can make it equal to 8, then we can make it equal to 2 as well. Like, we can make it 2 as well just by doing it more times, like 26, 26. And once more if I do, it becomes 32, 32. So if I can make them equal to either 4, 6 or 8, then I can make them 2 as well. Okay. So trying to make them 2 doesn't change our answer. Okay. If we cannot make them 2, then definitely we cannot make them these ones as well. Okay. So essentially what I'm trying to do is just trying to make all of the numbers equal to 2. I mean their unit digit, and then checking that can I make them all equal by checking their mod with 20. Alright. So that's the entire answer here. And now I can show the code to you. So in my main function, I have just fast IO and the call to solve function. And solve function, we have int n, c in n, int a of n, and c in the array. Now first I'll do is convert all the elements to even, right? Whatever are odd. So I'll iterate over the array. If ai mod 2 equal to 1, then I'll do ai plus equals to ai mod 10. So I do the operation, right? And if all of them are equal now, like, I'll count the occurrences of a0. Like, what this count function does is it takes two iterators, like a range, and it counts that in this range how many numbers are equal to this value. So I'm counting that how many numbers are equal to a0. So if it is equal to n, then all are equal, right? So if all are equal, then the answer is yes, right? Now if we have any 0 but the elements are already not equal, then print no. Like, if we have any 0 in our array but the elements are not already equal, then print no. So if I iterate over the array, and if ai mod 10 equal to 0, that means the last digit is 0, then print 0, right? Now what I will do is I will make all the unit digit to be equal to 2. Okay, so I'll iterate over the entire array. While ai mod 10 is not equal to 2, I will do ai plus equals to ai mod 10. So like, I'm just doing the operations until ai mod 10 becomes 2. Like, as you can see at this point, we don't have anything except for 2, 4, 6 and 8, right? Like, here I converted all the odd to even, and if we have any 0 right here, then we return, right? So at this point we don't have any 0 or odd, so we have only 2, 4, 6, 8. So I convert all of them to 2, and then also I take the mod with 20, right? So at the end I can check if all the mod with 20 are equal or not. So again I can count that in my array, if all the mod 20 are equal, like if the count of a0 is equal to n, that means all the numbers in my array are equal now, then the answer would be yes, otherwise the answer would be no, right? And the TC of this would be O of n, because all the steps that I have done are just O of n, right? This loop is O of n, this loop is also O of n, like this count function is O of n, then this loop also is O of n, and this loop and this function call, they are all O of n, right? And therefore the TC is O of n, and we did not use any extra space, so therefore the space complexity is O of 1. So TC is O of n and space is O of 1. Alright. So I hope you all understood this, and thanks for watching.